Hello guys, and welcome back shortly to this lesson titled The Inverse and the Composite of Functions. In this lesson, we focus on inverse functions and composite functions. Please make sure you watch this video to the end, as some of the most important concepts are at the end of the video. Equally, make sure that you click on the subscription button so that whenever we upload a new lesson, you will be notified in time. You can equally visit that blog on www.gcemathspanel.blogspot.com or gcemathspanel.com or gcemathspanel classes online, where you can have copy of these notes, quizzes, tutorials, and a lot more. Stay tuned as we advance. This lesson is prepared and brought to you by Maths 24, and we are going to show you some short tricks using the flowchart method and other methods. All right, so let's say an example of a plane that flies from Florida to Ontario, and it flies from Ontario to London. And let this route be the function g, that is from Florida to Ontario and Ontario to London. Let this route be the function g. Let's say the plane has to return, but must use the same route. The path will now be as follows. The path is going to be reversed and will be as follows. You can see the plane flying back to Florida now from London, and this is the path that the function traces. The path that brings the plane back to the origin is called the inverse function. This path that brings the function back to the origin, or the plane back to the origin, is called the inverse function, and is written as g inverse. If the function is g, then it is written g inverse, right? G inverse, not g to the power minus 1. This lesson is prepared and brought to you by Maths 24 Super Channel. We can give the inverse even without solving for it. So let's look at some simple tricks. Consider the following functions given: f of x and g of x and so on. You have the function add 5. The inverse is to subtract 5, and it can be written as g of x equals x plus 5. And the inverse will be g inverse equals x minus 5. If you have the function subtract 2, then the inverse will be add 2. For example, this is the function x minus 2, and the inverse will be x plus 2. So we are just doing the functions without going through calculations. The function multiply by 6 has inverse divide by 6, and this is the function 6x. The inverse will be x on 6. The function divide by 4 has inverse multiply by 4, and that gives us x on 4. The inverse, t inverse of x will be equal to 4x. So these are just some short tricks to get the inverse of functions without solving, but these are all one-step functions. What if you have two-step functions or more? What are we going to do in those cases? You can still use the same step, okay? Now find the inverse of f of x equals x plus 3. So start by saying x plus 3, that gives us x plus 3. This is a flowchart method. And to get the inverse, we start now from the end, we subtract 3 to come back. The inverse function is x minus 3, and written as f inverse of x equals x minus 3. Example 2, find the inverse of the function t of x equals 5x. So flowchart, we start from x, we multiply x by 5, and we'll have 5x. The inverse, we start with x, and we divide by 5 to have x on 5, which is the inverse function. Example 3, we have the function 2x plus 3. To find the inverse, we first of all take x, we times it by 2 to have 2x, but we are not yet at 2x plus 3. So after timesing it by 2 to have 2x, we now add 3, we have 2x plus 3. The inverse function, we start at the end and take the last operation. So we start with x, the last operation is plus 3. So the inverse is minus 3. That will give us x minus 3. Now, instead of timesing it by 2, we divide by 2 to have x minus 3 on 2. This is the inverse function written as h inverse of x equals x minus 3 on 2. Example 4, to find the inverse of this function g, we first take x, we add 5 to have x plus 5. The next step is to divide by 4. We divide by 4 to have x plus 5 on 4. For the inverse function, we start at the end, and that will give us x. Instead of dividing by 4, we multiply now by 4 to have 4x. Note that you must start with the last operation. You have 4x. Now, instead of adding 5 now to it, you subtract 5 to have 4x minus 5. The inverse function is h inverse of x equals x 4x minus 5. So these are short tricks which you can have the inverse of functions. Now let's look at the second method. This is a method now of analysis in which we let g of x be equal to y and we solve. Okay, yeah. So this is a one-step function. So in this case, we say let g of x be equal to y, and from there we are going to solve for one-step function and two sub functions and so on. We can use these methods to get the results of all of these functions. Okay. So the first thing to do, replace g of x by y, and this will give us y to be equal to x plus 2. Then we are solving for x, so solving for x will have y. Now we subtract 2 from both sides, will give us x. So our x is equal to y minus 2 when you swap the sides. Okay, so our inverse function will now be equal to f inverse of x, or g, because the function is g inverse of x will be equal to x minus 2. So that will give us g inverse of x will be equal to, replace y by x minus 2. So this is a method of analysis, guys. This lesson is completely found on Math 24 Super Channel. Go to Math 24 Super Channel and get this complete lesson there. Thus, the inverse of the function x minus 2 is x plus 2. And note that the function maps element from the domain to the codomain, while the inverse function maps elements back from the codomain to the domain, or from the range back. Let's just take this other function. We replace g of x by what? By y. So y is equal to 3x minus 5. We now add 5 on both sides of the equation, as you can see. That will give us y plus 5 equals 3x. We now divide all through by 3. Dividing all through by 3 will give us x to be equal to y plus 5 on 3. And therefore, our inverse function will be, after replacing or swapping sides, our inverse function now be equal to, replacing x by f inverse of, or g inverse of x rather, be equal to x, replace y by x, plus 5 on 3. Now equal to this other function, we replace h of x by y. We replace it by y. So y will be equal to x minus 1 on 7, right? So our y here is equal to x minus 1 on 7. And then we multiply both sides by 7. We'll have 7 y's to be equal to x minus 1. We add 1 on both sides of the equation. We'll have 7 y's plus 1 is equal to x. We already have the value of x, right? So x is equal to 7 y's plus 1. We are now going to replace x by, what's the function? Is h of x, right? So we replace x by h inverse of x. That should be equal to, replace y by what? By x, 7x plus 1. And this thing is as simple as ABC, but be careful with functions like minus 2x plus 4. Be very careful with this type of functions, because these functions are three-step functions. Now, guys, let's look at the composite of a function. What are composite functions? A composite function is a function of another function. Those are composite functions. It's a function of another function, or we can say it is a function of another. So let f and g be composite functions. Some functions will be as follows. These are some examples of composite functions. We have g of f, g of f. We have f of g, g of g, f of g of f. These are all composite functions. F of g inverse, f inverse of g. The list is endless. We equally have f plus g, f of g plus x, that's f minus g, 2f plus 3g, example. All these are composite functions. So it can be the sum of functions, difference of functions, and so on. So the following notations are the same. F of g is the same as f of g of x. At times they ask a question like that. It's the same also as f of g of x. All these notations are the same, okay? So this single notation can be written like this for all of these functions. Just f of g can be written in all of these ways. So take note of this if you're at advanced level, where f of g of x means do g first. So we start by operating with g first, the last function that appears, and then f. So we start by operating with the last function that appears. The last function that appears in this example is g. So we must do g first, and then f can follow, okay? Yeah, that's good. Let's take some examples. These examples will help master the concept, but practice more. Okay. Yeah. So given f of x equals x plus 2 and g of x equals 5x, find the following. Find f of g of x, which is equal to, so this give us in the function f, substitute g. So I'm going to have f of g of x. I'll replace g of x by its value there. That give me f of 5x, right? Now in the function f, wherever I see x, I'll replace the x by 5x rather. So this gives us 5x plus 2, 5x plus 2. That's the composite function. Another example, find g of f of x. In the function g now, replace x by f of x. That's what this means. So this is going to give us g of what, guys? All right, g of f of x. I'm now going to replace f of x in that position. I'll have g of x plus 2, right? Good. Now in the function g, I'm going to replace that x by x plus 2. So this will be equal to 5 into x plus 2. 5 into x plus 2. Are we together there? Yeah, good. So we can expand now and simplify. That gives us 5x plus 10. That's the composite function. Wow. Composite function, so sweet. Find f of x. Many examples here. So in the function f, replace x by f of x. So this gives us f of x. That will give us f of x plus 2. And I'm going to replace x in that function by x plus 2. So we'll have x plus 2 plus 2. That gives us x plus 4 as the composite function f of x. Yeah, x plus 4. Then the composite function g of f of 5. So we can first start by looking for g of f. We already have g of f, right? With 5x plus 10 now. Yeah, or we can look for f of 5 and then we substitute in that function. This one can be done in many ways. There's no problem. So we'll have f of 5 is 5 plus 2. So we have g of 5 plus 2, which is g of 7. And g of 7 will be equal to 5 times 7, right? Because x is 7. It's not 57. Be very careful, guys. Yeah, 5 times 7. Note, it is multiplication. Yeah. So we have g of 5 times 7, and that's going to give us g of 5 plus 7 to be equal times 7 to be equal to 35. Now find the function g of f inverse. Just by looking at f, the inverse function of f of x is x minus 2. Note that, right? So this gives us the function g of f inverse, which is x minus 2. That's a one-step function now. Yeah, so g of x minus 2, because f inverse of x is x minus 2. So we have g of x minus 2 from the previous lessons. So this is going to give us 9 in g. So we're going to have 5 times that x minus 2. And that's going to give us 5x minus 10. Yeah, 5x minus 10. And don't forget to click on the subscription button for this lesson, guys, and you can visit our blog. And to be a genius, you need to solve more problems to be a pro. That's very important because our lives are all functions. So please subscribe. This lesson is proudly brought to you by Math24 Super Channel. You can go online and subscribe to this channel to support our workers equally to produce more videos for you to prepare for your GCE. Our next function is on injective, surjective, and bijective functions. Bye-bye.